All right, so we talked about, this is where we get into random sampling. The biggest thing you need to know about random sampling is everyone has the same what? Chance. Write that down. Everyone in the sample has the same chance. And there it is right there, using chance to select. Everybody has the same chance. A good example of a random sample is if I put your name on a Post-it note and I fold that Post-it note in half and I put it in a fishbowl and I mix it up and I pick a name out of it, that is a random sample. So use the fishbowl analogy for a random sample because everybody has the same chance. Now, what if I say a simple random sample? I don't know if they're going to ask you this or not, but I'm going to give it to you. A simple random sample is putting these three on a piece of paper and calling it Group A. And then the three that have their video on, call that Group B. And then the next three, call that Group C. The next three, Group D. And the next group, Group E, as in echo. And I have 5 slips of paper. I call one A, B, C, D, and E. And I put those 5 into the fishbowl. So I only have 5 pieces of paper to pick from. That is called a simple random sample. What's the difference between a random sample and a simple random sample? A random sample is individual. A simple random sample is a group. So make sure you make that distinction because that could be a standardized test question. Okay? Random sample and simple random sample. Now let me ask y'all a question. What if Miss Hicks, being the rebel that she is, let's say that she doesn't use a yellow Post-it note, she uses a pink Post-it note and puts her name on it and puts it in the fishbowl.
You have a work email.
Is it still a random sample? Technically, no, because whoever's drawing the name, are they going to see that pink in a fishbowl? Are they going to see that pink piece of paper? Yes. Is that going to influence them at all? Yes. Because either they're going to pick that piece of paper or they're not going to pick it, they're going to get away from it. Because does that influence the drawing? Yes. Anything that influences the outcome is called bias. Okay? And we're going to talk about that in just a moment. And there's a definition, so you don't have to write it down right now. Next page. And there's simple random sample. Simple random sample is a group. Really? You're going to spend 3 pages on that? Okay. Good gracious. Oh, so that's all? Are you kidding me? They just spent a whole section on 2 words? I believe they could have.
Do we need to know what a frame is?
A what?
A frame?
Spell that.
Frame. F-R-A-M-E.
I have no idea what they're talking about.
Okay.
What did they ask a question like that in the homework?
No, I'm just saying it's one of the bold words in the textbook.
No, I've never heard of it, so I don't know what they're talking about. Hold on a second, I'm getting there. Okay, here we go. The next type of sample, okay, I know why. Usually they talk about all these samples in one section. Does that make sense? I don't know why they broke it up into two sections, but anyway. The next type of sample is a systematic random sample. Now this would be the third best sample that you would use. Why is a systematic random sample? Because if you've got a large group, let's say of 2,000 people or 4,000 people, and you don't want to survey all 4,000 people, then the best route to go is a systematic sample. You pick every 10th person in the phone book. You let the computer pick every 100th person. You go out to the parking lot, and every 5th person that walks out the door, front door, you ask them a question. That is called a systematic random sample. Ms. Hicks, you still with us? She disappeared on us. Oh, there she is. She went in and out. Sorry, I saw you disappear and I thought something was wrong. Okay. Systematic random sample. That is a very patterned sample, and it is the best besides random and simple random. And then after systematic, we're going to stratified, cluster, and convenience, with convenience being the least accurate. There's a cluster. A cluster is obtained by selecting all individuals with randomly selected collection or group of individuals. Voting precincts would be like clusters. If I wanted to go survey a cluster of people, a voting precinct would be a cluster. And I just want you to be able to name the different samples and to be able to, do an example, okay? They give you examples in the book. I just throw out one like a voting precinct. They say that a city block is a cluster. Yeah, that could be a cluster. Next should be stratified, I think.
It's the first one.
Huh?
Stratified came before.
Oh, it did?
Yeah, it was on page 20.
Stratified is never at the beginning. Never. This book is bass-accurate sometime. Hold on, let me go by and where is stratified? They never put stratified first. Which page is it on? It must be on this page. 28. Now, stratified. Stratified is, I don't know why they put stratified first. I think this is the first book I've ever seen put stratified first. Usually stratified is after cluster because you go into the cluster and break it up into different stratum. Okay? Like if I go into my cluster sample and break it up into Democrats and Republicans, or male and female, or below 25 and above 25. I go in and I break up the cluster into more groups. Now, do you understand why they put stratified after cluster in most books? I have never seen a book start off different effective sampling methods with stratified. Never. But there's something new every day. Now let me get back to convenience. Convenience is usually last because convenience is the least relied upon or the most prone to be inaccurate. Why? Well, let me give you an example. Let's say that I worked as a disc jockey. I don't know what you call them now because I know disc jockey is probably not politically correct, but I work at a radio station, and the station that I work at, all they play is 80s rock, which beside the 60s is the best rock. Okay, 80s rock. And I'm taking a night class in probability and statistics, and I've got a project that I need to do, and I've got to get it done, and I've got to survey 100 people, and it doesn't matter. So what I decide to do is I get on the air one night and I say, okay, I need your phone calls right now. I want you to tell me what kind of music you like to listen to. Well, what's wrong with that scenario? So what are they all going to say? Okay, that's why a convenience sample is not accurate. A convenience sample is when you work at Walmart and you ask people where they like to shop. Well, let me change that. Target. I used to work at Walmart. Back when I worked at Walmart in the late 80s, that was the place to shop. But now I wouldn't go there. Only time I go there is before 9 o'clock a.m. That's because stupid people don't get out till after 9. So, Target. Let's go with Target. Why do you shop at Target? Or where's the best place? You're going to get everybody there that surveys. They're going to say Target. So it's kind of a self-defeating sample. And somewhere in the book, it should say it's unreliable. I don't know, this book may tell you it's the best thing since sliced bread, since they put stratified first. It doesn't even come alphabetically correct. Stratified, I don't understand why they have it first. That bothers me. I guess y'all can tell that. All right. Now, do you need to know this for my test? Probably not. But do you need to know it for a standardized test? Yes. And that's why I took a minute to go over those different samplings. There's an example of a systematic sample. Simple random sample, a stratified sample, a systematic sample, got these all backwards, and a cluster sample. Wow, they spent 2 sections on 7 words or 6 words. Wow. All right, somebody tell me, do we go to 1.5? I think we do, don't we? Look in your handy dandy outline. I think we do. Say again?
Yeah, we do.
Okay, thank you. All right, bias. That is a number 1 word to be tested on, whether it's a standardized test or Hubert's test. I will test you on that word. I actually had a student tell me that I spent too much time on bias. Okay, no, when you're talking about probability and statistics, you can't spend enough time on bias. In my opinion, there's 2 professions that are non-biased. They should be non-biased. Anybody know what those 2 professions are? Anybody want to take a stab at it? No, that don't count. Bless you.
I told you wrong. We do 1 point.
Say again?
I told you wrong. We do 1.4 after 1.3.
Okay, we just went through 1.3 and 1.4, didn't we? Okay, 1.5 is what I was asking. Did we go through 1.5?
Yes.
Okay, I wanted to make sure because sometimes Bias. I want you to write down the sample of bias, and then I'm going to give you the two professions. Bias, well, that don't. If the results of the sample are not representative of the population, then the sample has bias. Okay, that's one definition. Another definition of bias would be leaning toward a certain belief. Why is this so important in probability and statistics? Well, you know, it's kind of like forbidden fruit or poison fruit. In a trial, you don't use evidence as poison. You don't use it because it will taint your case. And in probability and statistics, if you have one whiff of bias, it'll blow your whole project. You can have biased surveys, you can have biased questions, you can have biased interpretations, and you can have biased presentations. Okay? This is no joke. The person that complained that I spent a lot of time on bias actually said that I was spending too much time on it because of politics. I was like, really? You're talking about a probability and statistics course. The number one thing that you need to talk about is bias. Anyway, so what can be biased? The whole process could be biased. The two professions that I tell you are non-biased or should be non-biased is a referee and a what? A judge. Now, I've seen this before. I've seen it in circuit court. I've been in circuit court with, I'm on a land use board, and sometimes sometimes our decision on the land use board goes to circuit court, and I go to the circuit court whenever I need to, and I've seen the judge actually go right down the middle and say, I have to be down the middle on this, and he give a reason. And if you ever watch judges, they have to be right down the middle. Same thing with a referee, unless you're a Clemson fan, and if something goes wrong, what do? You blame it on referees. So in many cases, those are the two professions that should be right down the middle. When you are doing any type of research, especially in a probability and statistics format, you have to be careful of bias, of being biased. Okay? Let's say that I sent out a questionnaire and one of the questions says, you don't want this person to be on council, do you? Yes or no? Well, what's wrong with that question? It's a leading question. It's a negative leading question. You don't put in a survey, you don't want this person to be blank. You don't say that. That's a biased question. And you can make questions open and you can make them biased. And you can bias the whole, and once you start with that bias, it just keeps on going. Sampling bias. Under coverage, that's one thing. Let me give you an example. I'll give you an example of a biased survey. I surveyed 10,000 people across the United States, and they said that they wanted this person to be dog catcher. Okay? And I went South Carolina, Georgia, Mississippi, Alabama, New Orleans, New Orleans, Texas, and Arizona, and Nevada, and Southern California. Well, did I go across the United States? Pretty much. But what didn't I tell you? What part of the United States did I go across? Geography people, tell me what part of I went across the South. Yeah, that's right, class. I went across the South of the United States, which feels differently than the North. Okay? I don't know, dog catcher, whatever the case may be. Okay? I can also do an undercoverage. I can also say, well, instead of 10,000 people, I'm going to ask 100 people because I know what they're going to say, so I'm just going to say 100. Okay, those are examples of bias. Okay? If I go out and ask people, a question, I want to act like I have no idea what their answer is going to be. That's called non-bias. Non-biased response exists when individuals selected to be in the sample who do not respond to the survey have different opinions from those who do. That's a good little part to read right there. You don't have to read it, but it's a good, there are some people that if you don't respond to a survey, you know what they'll put down? They'll put down that you're either in favor or not in favor of whatever the survey's measuring. That's not right. Okay? This has been a subject that has been talked about for the last 3 or 4 years. Bias, especially with our media. Response bias. Interview error. Sometimes interview error and the researcher error is by accident. And sometimes it's what? On purpose. And we'll get to that in just a minute when we get to graphics. Here's some examples. Do you oppose the reduction of a state tax? Do you favor or oppose the reduction of a state tax? See, that's a biased question because it is leading you to what? It's leading you to oppose. Now, a lot of people wouldn't even think about that, but again, you've got to be right down the middle. When you're surveying, when you're taking in data, when you're calculating data, and when you're interpreting data. You can't be biased. Do you think the United States should forbid public speeches against democracy? Do you think the United States should allow public speech along democracy? I would say probably B is the better question. Do you think the United States should let communist newspaper reporters from other countries come in here and send back to their papers the news they see as they see it? Do you think a communist country such as Russia should let American newspaper reporters come in and back? See, it's in order. When you do ordered questions, that can lead a person to a conclusion. So it's a little piece that I would highly suggest that you read, these 2 or 3 pages. Okay? The wording of a question can significantly affect the response. Very, very important. An open question, these are 2 definitions that you need to know. An open question is a question that has the person explain. Okay? You can say yes or no, but usually they want you to explain. A closed question, you have to pick the answer from a series of, multiple choice, or say yes or no. What is the most important problem facing America's youth today? Boom. And you got to pick from one of those. That is called a closed question. An open question would be like that right there. Now there's good for both. That depends on what the content of the question is. Anything can have a bias. Anything. If you send out a questionnaire, whether it's a census or whether, depending on how the questions are worded, can be biased. The only thing that cannot be biased is a blank sheet of paper. And that's 1.4, wow, or 1.5. We didn't even get into misrepresentation of graphics. That might be in chapter 2, I don't know. So that is basically 1.1 through 1.5. Now, I think we go 2.1 through 2.3, correct? Thank you. A frequency distribution. Write that down. A frequency distribution is a 25-cent word for a table or a chart where you have categories on the left and head count on the right. Think of blondes, brunettes, and redheads. Blondes, brunettes, and redheads. 5, 4, 3. 5 blondes, 4 brunettes, 3 redheads. You got a category on the left and a head count on the right. That's a frequency distribution. Qualitative data, you really can't do anything with a frequency distribution with qualitative data because you have categories. You can do mathematical operations with quantitative data on a frequency distribution because they don't have categories on the left. Write this down. They have classes. And classes can be mathematically manipulated. You're going to see an example here in just a minute. Well, there it is right there. That right there, here's your data. Back, wrist, elbow. This is a qualitative frequency distribution. Why? Well, somebody give me the average of the body parts. Can. Okay? So, since you can't take the average of back plus wrist plus elbow plus hip, that's like finding the average of blonde, brunettes, and redheads. You can't do it. So the only thing you can do is put them in categories. And this is called the frequency. The frequency is a 25-cent word for head count. And that is a frequency distribution. I think some person a long time ago decided that they couldn't do mathematics, so they wanted to have a title, and because they couldn't become a mathematics person, so they decided to break off and make statistics and make a bunch of fancy words so that it makes them sound like they were important. A table, this is nothing but a table, okay? But in statistics, it's called a frequency distribution. And this is a qualitative frequency distribution because it is made up of categories, not classes. Capiche? Yeah, I understand, Hubert. Good, class. Here is your qualitative data, and it's asking for the relative frequency. Does anybody know what what the relative frequency is a fancy name for? Percentage. So relative frequency, right out to the side of that, and highlight, because that's what it is, it's a percentage. So the first thing you do is put 12 over the total, then 2 over the total, then 1 over the total, then 2 over the total, then 4 over the total, then 5 over the total. And that's called the relative frequency. Now, I'm not spending a lot of time on this because I don't want to insult your intelligence. I think everybody in here can figure out how to find a frequency distribution, a relative frequency of 12 over 30. And of course, the 30, you add up all the head count, that's your total. So that's a good example to write down. I'm giving you another minute to write that down, because I will ask you the relative frequency on a test, and it'll look something like this. You could have classes over here from 18 to 20, and from 21 to 24, and 25 to 30, and 31 to 34. You could have classes, but that does not enter into the relative frequency. The relative frequency is equal to the number, the head count, over the total head count. I'm not going to make you write that definition of a bar graph. I'm just going to tell you to draw it. There is a bar graph. Okay? You can write that definition down if you want to, but I think it's easier for a person just to write a bar graph and then draw a picture of one. To me, that's a better definition. This is the bar graph of the head count. This is the bar graph of the frequency distribution. The relative frequency. And they match. Why do they match? Because the numbers match. The relative frequency is built off the numbers. So naturally, the head count curve is going to look exactly like the relative frequency curve. They're going to match. So will I ask you a question on calculating the relative frequency? Yes. Will I ask you a question on graphing the head count or the relative frequency? Yes. Can you do it on a calculator? Yes. I'll show you when we get there. When we start working with the calculator, I'll show you. Go ahead and write down a Pareto chart, because it's important that you understand what a Pareto chart is. Not for me. I'm not going to test you on this, but you need to know the difference between a Pareto chart and a bar chart. A Pareto chart is a bar graph that doesn't put the bars in the same order as the numbers. It puts it in decreasing order. So a Pareto chart will always look like a decreasing curve because it's in decreasing order. It changes the order of the natural the frequency distribution into decreasing. So this one would go next. Knees would go next, then shoulder would go next, then these three, then these three. And that's what they did. A Pareto chart descending order. They're used a little bit, but they're not used that much. But you need to know the difference. You need to know what a Pareto chart is. I'll give you a minute to draw that picture if you want to. That way you'll have it in your notes. I'll try to finish this section up. Yes?
With the horizontal bars, since they're going sideways, does that change which line the X and Y axis are on? Or is it still the same?
No. Is that the next page? Do they go, what page is that on?
It's right, yeah, I guess.
Yeah, just hold on just a second. We'll get to that in just a second. All right. Here they give you another set of data and they put side by side. Usually you can do this side by side. That's not a big deal. I'll show you how to do that on Excel spreadsheet, but that's a side by side chart. You don't have to write that down. Just know that there are side by side charts and you're comparing this guy with this guy and 47,000 to 61,000 and 29,000 to 34,000. And that's what this is right here. They're horizontal bars. That's what you're asking. Horizontal bars. Let's see, the relative frequency on that same one. Yes, the relative frequency stays the X. Yes. The relative frequency on the previous. Yeah, see, it switches. So your y-axis becomes your x-axis. That's what she was asking. She was asking, does the y-axis become the x-axis? Yes. Why do people use this? It's nothing but preference. Presenter's preference. When I first started at Tri-County Tech, they gave me this position and they told me they wanted me to present. And I had a mentor that kind of helped me, put stuff together because I was new and I was a student out of Clemson, just finished. And I went in there with a presentation to present, at the end of the year. And she said, no, 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 no. And it was like 15 or 20 pages. And it was all PowerPoint presentation. Back then, PowerPoint was new. And she just looked at me and gave it back and said, no, 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 no. She said, you got 5 minutes to present and it has to be on the level of a sixth grader. And I was like, what? She said, administrators don't want all the glitz and glamour and all the details. They just want to know, get to the point. KISS method. So I took that and I never forgot that. When I put it to this day, when I put a presentation together for a department head or for a dean or whatever, I put it on a sixth grade level. Now, what does that have to do with the bar charts? Are you going to put together a bar chart that is complicated? Or are you going to put together something that's simple? Simple. KISS method. Keep it simple. And that's why the best chart to use is a pie chart. I will test you on a pie chart. I'm not going to test you on I'm just going to make sure you can read it, okay? A pie chart is the most used when it comes to business and economics. I didn't say probability and statistics, but it is used in statistics. A pie chart is a circle divided into sectors. Y'all all know that. You've seen them before. And here is an example. Right here. First thing you do is you change your numbers to percentages, relative frequency. And then you put that in the form of a pie chart. Now, the good thing about this is Excel will draw you a pie chart or a bar chart in a matter of seconds. And don't worry, I'm going to show you that in chapter 3. But in this case, here is your example right there. And they're going to turn that into a pie chart on the next page. And there is your pie chart. So go ahead and just make an example of that pie chart. And that's probably going to finish this section of 2.1. And we are finished because it's 8:57 and some of y'all are going to go into convulsions. So we need to go ahead and cut off the recorder. I don't need to. Yes.
So we need to do 1.3, 1.4, 1.5, and 2.1.
Yes, you should be working on those. Now remember, what is it? 1314, that was only on 6 words. So the homework can't be that bad. I don't know how many's on it. But yes, right now, you should be working on 1.3, 1.4, 1.5, and 2.1 material in the homework.
Are your tests like the homework?
Mm-hmm. We went over the test, didn't we? Did we go over the test in here?
The bonus one.
Yeah, they look just like, yeah, but I showed you the math questions, right? They come from the homework. Okay, sometimes I mention that, sometimes I don't. Y'all can go because I've already called the roll unless you got questions. I'm going to shut off the recording. And those of you that have questions, you're welcome to ask them.
Have a good day.
Now, you too, man. Y'all be careful.